Right now, as you're watching this video, there are mysterious worlds spinning in the darkness beyond Pluto that NASA has been quietly discovering. Worlds so bizarre they're rewriting everything we thought we knew about our solar system. These aren't just random chunks of ice floating in space. These are full-blown alien worlds with their own moons, ring systems, and physics-defying properties that would make science fiction writers jealous. But here's the kicker. Some of these discoveries are so recent that most people have never even heard their names. Did you know there's a world out there that spins so fast it literally stretched itself into the shape of a football? The dwarf planet that dethroned Pluto. Did you know there's a world out there so massive it literally kicked Pluto out of the Planet Club? Meet Eris, the cosmic troublemaker that changed everything we thought we knew about our solar system. This icy giant sits way beyond Pluto's orbit, roughly 68 times farther from the Sun than Earth, making it one of the most distant objects we've ever discovered in our neighborhood. What makes Eris absolutely mind-blowing is that it's actually 27% more massive than Pluto, despite being slightly smaller in size. Think of it as the dense, muscular cousin that nobody talks about at family gatherings. When astronomers first spotted this beast in 2005, it sparked the Great Planetary Identity Crisis that ultimately led to Pluto's demotion to dwarf planet status. But here's where it gets really wild. Eris is so far out there that it takes 557 Earth years just to complete one single orbit around our Sun. The surface temperature, a bone-chilling -400 degrees Fahrenheit, cold enough to freeze nitrogen solid. Named after the Greek goddess of chaos and discord, Eris lives up to its reputation by having an orbit so elliptical and tilted that it literally dances to its own cosmic rhythm. This frozen world even has its own moon called Dysnomia, named after Eris's daughter who was the goddess of lawlessness. Together, they're like the ultimate rebel duo of our solar system, proving that the most interesting characters always hang out in the shadows. The Easter Island of space. What if I told you there's a world out there named after an Easter Island creation god that's hiding secrets NASA never expected? Welcome to Make, the reddish dwarf planet that's rewriting the rules of what we thought possible in the outer solar system. This bizarre world sits about 45 times farther from the Sun than Earth, cruising through the Kuiper Belt like a cosmic ghost wrapped in mystery. Here's what makes Make absolutely fascinating. Its surface is covered in frozen methane and nitrogen, giving it this eerie reddish-brown color that makes it look like a giant rusty marble floating in space. But the real shocker came when scientists discovered that this supposedly lonely world actually has a tiny dark moon they nicknamed MK2. This little companion is so dark it absorbs almost all light that hits it, making it nearly invisible and explaining why it took astronomers over a decade to spot it after finding Make itself. The temperature on this frozen wasteland? A brutal -406 degrees Fahrenheit, so cold that even the atmosphere would freeze solid if it had one. What's really mind-bending is that Make completes one orbit around our Sun every 310 Earth years, meaning since its discovery in 2005, it's barely moved from where we first spotted it. Named after the Polynesian creator deity from Easter Island, this world represents one of the most significant discoveries in our solar system's outer reaches, proving that even in the darkest, coldest corners of space, there are still incredible surprises waiting to be uncovered. The spinning football planet. There's a world spinning so fast in our solar system that it literally stretched itself into the shape of a football, and it comes with its own ring system that shouldn't even exist. Say hello to Haumea, the cosmic speed demon that's breaking every rule we thought we knew about how planets behave. This elongated freak of nature rotates once every 4 hours, making it one of the fastest spinning objects in our entire solar system. So fast that centrifugal force has warped it into an egg-like shape that's twice as long as it is wide. Located about 43 times farther from the Sun than Earth, Haumea is essentially a giant spinning ice ball made mostly of crystalline water ice, reflecting sunlight so brilliantly that it practically glows in the darkness of space. But here's where things get absolutely insane. This spinning football has two moons, Hi'iaka and Namaka, named after Hawaiian goddesses, and they're likely chunks that got flung off during some catastrophic collision billions of years ago. The real kicker? In 2017, scientists discovered that Haumea has its own ring system, making it the first known ringed object beyond Neptune. These rings are incredibly thin and dark, orbiting around Haumea's equator like a cosmic hula hoop. What makes this discovery so shocking is that according to everything we know about physics, rings shouldn't be stable around such a rapidly rotating, oddly shaped object. Yet, there they are, defying our understanding and proving that the outer solar system is full of impossible worlds doing impossible things. The Lonely Wanderer. Ever wonder what happens when a world gets so lonely that it takes 11,400 years just to say hello to the sun once? Meet Sedna, the cosmic hermit that's rewriting everything we thought we knew about the edge of our solar system. This blood-red dwarf planet is currently sitting about 84 times farther from the sun than Earth. But here's the kicker. Yeah, that's actually its close approach. When Sedna reaches its farthest point in its orbit, it ventures out to a mind-boggling 937 astronomical units away, making it so distant that the sun would look like just another bright star in the sky. What makes this world absolutely fascinating is its deep crimson color, caused by organic compounds called tholins that have been baked by cosmic radiation for billions of years. The surface is a frozen wasteland of water ice, methane, and carbon dioxide, with temperatures that never rise above -400 degrees Fahrenheit. But here's where Sedna gets really mysterious. Its orbit is so extreme and elongated that something massive must have gravitationally yanked it into this bizarre path billions of years ago. Scientists think it could have been a rogue star that passed through our solar system when the sun was young, or maybe even evidence of the legendary Planet 9 lurking in the outer darkness. Sedna rotates incredibly slowly, taking about 10 hours to complete one spin, and it's completely alone out there with no known moons. This lonely wanderer represents our first glimpse into the inner Oort cloud, that mysterious region where comets are born. The Ancient Surprise. There's a world out there that's completely shattering our understanding of physics by sporting rings that absolutely should not exist. Meet Quaoar, the rebel dwarf planet that's making scientists question everything they thought they knew about how ring systems work. This icy troublemaker sits about 43 times farther from the sun than Earth, cruising through the Kuiper Belt with a secret that wasn't discovered until 2022. Named after the creation deity of the Tongva people of Southern California, Quaoar is roughly half the size of Pluto, but packs enough surprises to keep astronomers scratching their heads for years. Here's what makes this world absolutely mind-blowing. It has a ring system that orbits at a distance where rings simply cannot exist according to our current understanding of celestial mechanics. These rings sit way beyond what's called the Roche limit, the theoretical boundary where a planet's gravity should tear apart any orbiting material and turn it into moons instead. Yet Quaoar's rings are just hanging out there, perfectly stable, basically giving physics the middle finger. The rings themselves are incredibly faint and narrow, made up of tiny particles that somehow resist clumping together into larger objects. What's even more bizarre is that Quaoar has a small moon called Weiwat, named after Quaoar's son in Tongva mythology, which orbits much farther out than the rings. This setup defies everything we know about how ring systems should behave, suggesting there are fundamental forces at work in our solar system that we're only just beginning to understand. Pluto's anti-twin. What if there's a world out there that's locked in a cosmic dance with Pluto, orbiting in perfect harmony but always staying on the exact opposite side of the solar system? Welcome to Orcus, the anti-Pluto that's proving the universe has a twisted sense of symmetry. This dark, mysterious dwarf planet sits roughly the same distance from the sun as Pluto, about 39 times farther than Earth, but here's where things get absolutely wild. It's trapped in what scientists call a 1-to-2 orbital resonance with Pluto, meaning for every 2 orbits Pluto makes, Orcus completes exactly 1. But the real kicker is that they're positioned like cosmic opposites, always maintaining maximum separation as they waltz through space together. Named after the Roman god of the underworld and punisher of broken oaths, Orcus is significantly smaller than Pluto but shares some eerily similar characteristics. Its surface is covered in water ice mixed with organic compounds, giving it a grayish appearance that makes it look like Pluto's shadow twin. The most fascinating part? Orcus has its own moon called Vanth, named after an Etruscan demon, and this moon is unusually large compared to its parent, almost like a mini version of the Pluto-Charon system. What makes this relationship so bizarre is that despite being gravitationally linked in this eternal dance, Orcus and Pluto will never get closer than about 18 astronomical units apart. They're like cosmic dance partners who are forever destined to mirror each other's movements while never actually meeting, creating one of the most elegant and mysterious orbital relationships in our entire solar system. The Chaos Bringer. There's a world tumbling through space so chaotically that scientists can't even figure out which way is up, and it's named after a Chinese water god known for causing floods and chaos. Meet Gong Gong, the cosmic troublemaker that's spinning in such a bizarre way, it's making astronomers question everything they know about planetary rotation. This dark reddish dwarf planet lurks about 67 times farther from the Sun than Earth, taking a whopping 554 years to complete just one orbit around our star. What makes Gong Gong absolutely mind-bending is its rotation. Instead of spinning like a normal planet with a stable axis, it tumbles end over end in a completely unpredictable pattern that changes constantly. Scientists think this chaotic tumbling was caused by a massive collision sometime in its past, possibly the same impact that created its small moon, Xiangliu, named after Gong Gong's nine-headed serpent companion in Chinese mythology. The surface of this world is covered in dark, methane-rich materials that absorb most of the sunlight hitting it, making it one of the reddest objects in the outer solar system. Here's what's really wild. Gong Gong is so massive that it's right on the borderline of being large enough to pull itself into a round shape, but its chaotic rotation and composition keep it slightly elongated. The temperatures on this frozen wasteland never rise above -400 degrees Fahrenheit, cold enough to freeze nitrogen solid. This tumbling giant represents one of the most dynamically unstable objects we've discovered in our solar system, proving that even billions of years after formation, some worlds are still dealing with ancient cosmic trauma. The Slow Giant. There's a cosmic giant lurking so far out in space that it takes over 1,100 years just to say hello to the sun once. And, scientists almost missed it completely while hunting for dark energy. Meet 2014 UZ-224, nicknamed DD for Distant Dwarf, the slow-motion behemoth that's redefining what we know about the edge of our solar system. This mysterious world sits approximately 8.5 billion miles away from the Sun right now, making it nearly 3 times farther out than Pluto, and ranking it as the third most distant known object in the Kuiper Belt. What makes this discovery absolutely incredible is that it was found completely by accident. Astronomers were using the dark energy camera to map distant galaxies when undergraduate students spotted this single moving dot creeping across the cosmic background. The sheer size of this world is mind-blowing, measuring roughly 395 miles across, which makes it about 2/3 the diameter of the dwarf planet Ceres, and roughly half the size of Pluto. Here's where things get really wild. 2014 UZ-224 has one of the most extreme orbits ever discovered, swinging as close as 38 astronomical units from the Sun and reaching as far out as 180 astronomical units, creating an incredibly elongated path that takes 1,147 years to complete. The surface of this distant world is incredibly dark, reflecting only 13% of the sunlight that hits it, making it one of the darkest objects in our solar system. What's fascinating is that this world is currently headed inward toward the Sun and won't reach its closest approach until the year 2142. The Snowman of Space. What if I told you there's a cosmic snowman floating 4 billion miles away that's revealing the deepest secrets of how our entire solar system was born? Meet Arrokoth, the most distant object ever visited by a spacecraft, and the ultimate time capsule that's rewriting everything we thought we knew about planetary formation. This bizarre double-lobed world looks exactly like a flattened snowman, with 2 rounded sections gently touching each other in what scientists describe as the most gentle cosmic kiss ever recorded. Here's what makes this discovery absolutely mind-blowing. When NASA's New Horizons spacecraft flew by Arrokoth on New Year's Day 2019, it revealed that this ancient relic formed through a process so delicate that its 2 halves came together at just 7 miles per hour, essentially docking like spacecraft rather than smashing together violently. The surface of this primordial world is incredibly red, even redder than Pluto, and recent analysis has revealed something that could change our understanding of life's origins. It contains sugars like ribose and glucose, the fundamental building blocks of life itself. What's truly fascinating is that Arrokoth has remained virtually unchanged for 4.5 billion years, preserved in the deep freeze of the Kuiper Belt like a cosmic fossil. Scientists believe this snowman-shaped world formed when a localized cloud of primordial material gently collapsed and fused together, proving that planet formation can happen through surprisingly gentle processes rather than violent collisions. This discovery is revolutionizing our understanding of how planets form and suggesting that the building blocks of life might be far more common in the universe than we ever imagined. The Phantom World. What if there's an invisible giant lurking in the darkest corners of our solar system? A phantom world so massive it's secretly controlling the orbits of distant objects like a cosmic puppet master. Meet Planet 9, the theoretical super-Earth that could be the most significant discovery in astronomy since Neptune was found over 150 years ago. This mysterious world is believed to be roughly 10 times more massive than Earth, and orbits somewhere between 400 to 800 times farther from the Sun than our planet, making it so distant that it would take between 10,000 to 20,000 years just to complete one orbit around our star. Here's what makes this discovery absolutely mind-blowing. Scientists haven't actually seen Planet 9 yet, but they know it's there because of the gravitational fingerprints it's leaving behind. 6 distant objects in the Kuiper Belt all have their orbits mysteriously aligned in the same direction and tilted at the same 30-degree angle, something that would be virtually impossible without a massive planet shepherding them from the shadows. Computer simulations show that Planet 9's gravity is so powerful it could have tilted our entire solar system by 6 degrees over the past 4.5 billion years, finally solving a mystery that has puzzled astronomers for decades. Recent studies suggest there's at least a 40% chance this phantom planet actually exists, and it might be the core of a giant planet that was violently ejected by Jupiter during the chaotic early days of our solar system. With surface temperatures around minus 375 degrees Fahrenheit and a diameter 7.5 times larger than Earth, Planet 9 represents the ultimate cosmic hide-and-seek champion. So there you have it. 10 absolutely mind-blowing worlds that prove our solar system is way stranger than we ever imagined. From spinning footballs to phantom planets, these discoveries are just the beginning of what's waiting out there in the cosmic darkness. If these bizarre worlds blew your mind as much as they did mine, make sure you hit that subscribe button and ring the bell icon so you never miss our latest space discoveries. Drop a comment below and tell me which of these worlds surprised you the most. Was it the tumbling chaos of Gong Gong or the invisible giant Planet 9? Thanks for joining me on this cosmic journey, and I'll see you in the next Space Facts adventure. Beneath the Swiss-French border, the world's most powerful machine is unlocking secrets that could reshape reality itself. Did you know the Large Hadron Collider at CERN can recreate conditions a fraction of a second after the Big Bang? That's not just science fiction, it's happening right now, revealing mysteries that have puzzled humanity for centuries. Here's a punchline. Scientists once set out to create a black hole in the lab. Sounds wild, right? But do you know what really happened when they tried? The Big Experiment. Deep beneath the border of Switzerland and France, a machine hums with the energy of 1 billion lightning bolts. The Large Hadron Collider at CERN isn't just another scientific tool, it's the world's most ambitious experiment, designed to answer the deepest mysteries of our universe. Here, scientists accelerate tiny protons to speeds just shy of light itself, then smash them together in a controlled chaos that recreates conditions from the dawn of time. The stakes? Nothing less than rewriting what we know about reality. When the LHC first powered up, the world held its breath. What secrets would these collisions unlock? Could they reveal hidden dimensions, new particles, or even the birth of a black hole right here on Earth? The excitement in the scientific community was electric, matched only by the curiosity, and sometimes fear, of the public. For the researchers, each collision was a chance to glimpse the unknown, to catch a fleeting signal that could change everything. The LHC's detectors, massive and intricate, waited to capture every trace of the subatomic fireworks. Every second, data poured in, flashes of energy, trails of particles, whispers from the fabric of the cosmos itself. This wasn't just about smashing atoms, it was about pushing the boundaries of human knowledge. The world's brightest minds gathered at CERN, united by one goal, to unlock the secrets of existence, one collision at a time. And on that day, as the LHC roared to life, the stage was set for a discovery that could shake the universe. The black hole theory. Rumors swirled as whispers of black holes at CERN hit headlines, sparking debates from classrooms to coffee shops. The idea wasn't science fiction, it was rooted in real physics. Some theorists proposed that the extreme energies inside the Large Hadron Collider could momentarily create microscopic black holes, so tiny they'd vanish in a flash. These wouldn't be the monstrous cosmic beasts devouring stars, but subatomic blips, lasting less than a heartbeat. The theory was electrifying. If these mini black holes appeared, they could offer clues about hidden dimensions and the true nature of gravity. For physicists, the possibility was a golden ticket to test ideas that had only existed on chalkboards and in computer simulations. The world's media, though, latched onto the word black hole with a mix of fascination and fear. Headlines warned of doomsday scenarios, while scientists calmly explained the math. Any black hole produced would evaporate instantly, harmlessly, thanks to a process called Hawking radiation. Still, the buzz was unstoppable. People wanted to know, could humanity really create a black hole, even for a split second? The tension between groundbreaking discovery and public anxiety gave the experiment an edge of drama rarely seen in science. As the countdown to the first collisions ticked down, all eyes were on CERN, waiting to see if the wildest theories in physics would leap from the pages of textbooks into reality, even if only for the briefest moment. Public panic. The world watched with a mix of awe and anxiety, as news outlets ran wild with headlines about CERN potentially creating a black hole. Social media feeds exploded with speculation, fueling a frenzy that reached far beyond the walls of any laboratory. Parents worried about their children's future, conspiracy theorists spun tales of impending doom, and even some scientists found themselves fielding questions from concerned friends and family. Petitions began circulating online, gathering thousands of signatures from people demanding the experiment be stopped. Lawsuits were filed in international courts, arguing that humanity was on the brink of unleashing a catastrophe it couldn't control. The debate wasn't just confined to science journals, it became dinner-table conversation, late-night talk show fodder, and the subject of heated arguments on radio and TV. The tension was palpable, and for many, the line between scientific possibility and science fiction seemed to blur. Yet, amid the chaos, CERN's researchers remained focused, determined to separate fact from fear. They addressed the public's concerns head-on, holding press conferences and releasing detailed safety reports. Their message was clear, the science was solid, and the risks were virtually non-existent. But the spectacle of public panic had already taken on a life of its own, transforming a groundbreaking scientific endeavor into a global drama. As the countdown to the first collisions continued, the world held its breath, gripped by a mixture of curiosity, skepticism, and a dash of existential dread. The science behind it. Physicists at CERN knew the stakes were high, not just for science, but honestly, for public trust as well. As the world's attention zeroed in on the collider, experts really stepped up to explain the real science behind the headlines. The idea of creating a black hole in the lab was rooted in advanced theories, but the reality was, well, far less dramatic than the doomsday scenario suggested. According to the mathematics of Stephen Hawking, any microscopic black hole that might form would evaporate in a fraction of a second, releasing its energy harmlessly back into the universe. This process, known as Hawking radiation, meant that even if the collider succeeded in producing these elusive objects, they'd vanish before they could do anything at all. Scientists published extensive safety reviews, showing that cosmic rays, natural high-energy particles from space, strike Earth's atmosphere with far more energy than anything produced at CERN, and have been doing so for billions of years without any catastrophic consequences. The reassurance didn't stop the questions, but it did offer a foundation of calm in the midst of the storm. Researchers used every tool at their disposal, public lectures, interviews, and open days at the laboratory, to demystify their work and invite the public into the process. Their message was consistent. The quest for knowledge is never without risk, but the safeguards were robust, and the science was sound. For those who listened, the fear began to fade, replaced by a sense of wonder at the boldness of human curiosity. The moment of truth. Pressure built inside the control room as the countdown ticked closer to zero. Every scientist glued to their monitors, every eye scanning for the slightest anomaly. The world outside buzzed with anticipation, but inside CERN, focus was absolute. Years of planning, debate, and preparation all led to this moment. The first high-energy collision inside the Large Hadron Collider. Protons, accelerated to near light speed, hurtled toward each other in a tunnel colder than deep space. The instant they collided, a burst of energy erupted, brief, brilliant, and packed with the potential to reveal the universe's hidden layers. Detectors as tall as buildings and packed with cutting-edge technology snapped into action, capturing every trace, every spark, every whisper of something extraordinary. Scientists watched the data stream in, looking for any sign, a deviation, a flash, a particle signature that might hint at the creation of a microscopic black hole. The tension was electric, every second stretching into eternity as the world waited for news. Would the experiment confirm decades of theory, or rewrite the rules of physics altogether? The stakes were enormous, not just for the researchers but for everyone watching. In that instant, the boundaries between fear and fascination blurred, and the pursuit of knowledge took center stage. The world was about to find out if the universe would reveal one of its greatest secrets or if the mysteries would remain just out of reach. What the detectors saw. A surge of anticipation swept through the data centers as the first collisions unfolded, unleashing a torrent of information that only the most advanced detectors on Earth could decode. Scientists huddled around screens, eyes darting between streams of numbers and vivid bursts of color, each one a potential clue to something extraordinary. The detectors, engineered to capture the faintest traces of subatomic chaos, registered a symphony of particles and energy signatures. Flashes of exotic matter, fleeting and rare, danced across the monitors, each event meticulously catalogued and analyzed. But among the fireworks of quantum debris, there was no sign of a stable black hole, no gravitational anomaly, no runaway reaction. Instead, the readings matched the predictions: bursts of energy, showers of particles, but nothing that threatened to spiral out of control. The absence of disaster was, in itself, a triumph. Every blip and spike in the data told a story, confirming that the universe's rules held firm, even under the most extreme conditions humans could create. The experiment's outcome reassured not just the scientists, but a world that had been holding its breath. As the data poured in, it became clear that the LHC was not a harbinger of doom, but a gateway to deeper understanding. The detectors had witnessed the universe at its most fundamental, and what they saw was both expected and astonishing, a testament to the power of human curiosity and the precision of modern science. The unexpected discovery. What truly stunned the scientific community wasn't the arrival of a black hole, but rather the treasure trove of rare particle interactions that emerged from the chaos. As the detectors sifted through trillions of collisions, they began to reveal patterns and phenomena that had never been observed before. Among the swirling clouds of subatomic debris, researchers spotted fleeting traces of particles predicted by theory but never caught in action. Exotic combinations that pushed the boundaries of quantum physics. These discoveries weren't just statistical blips, they were windows into realms of matter and energy that had only existed in equations and speculation. Every new interaction, every anomalous signal, became a potential breakthrough, sparking debates and excitement across the globe. The LHC's ability to recreate these extreme conditions allowed scientists to probe the very fabric of reality, inching closer to answers about the universe's most profound mysteries. The unexpected findings fueled a surge of innovation, inspiring new experiments and theories that rippled through the world of physics. For the researchers at CERN, each surprise in the data was a reminder that the universe still held secrets waiting to be uncovered. The absence of a black hole didn't mean disappointment. Instead, it marked the beginning of a new chapter in discovery, where the unknown beckoned with even greater promise and wonder. Media frenzy. Wow, what a whirlwind it was! Newsrooms scrambled to keep up as the story of CERN's black hole experiment exploded across headlines, turning a scientific milestone into a global sensation. The media, always hungry for drama, seized on every possibility. Some outlets painted the experiment as a bold leap for humanity, while others stoked fears with talk of doomsday scenarios and runaway black holes. Social media platforms became battlegrounds of opinion, with hashtags trending worldwide and heated debates erupting in comment sections. Scientists suddenly found themselves thrust into the spotlight, fielding interviews and answering rapid-fire questions from reporters eager for a soundbite. The narrative shifted almost hourly, swinging between awe at the scale of human achievement and anxiety over the unknown. For many viewers, the spectacle was irresistible, a real-life science thriller unfolding in real time, with the fate of the planet seemingly hanging in the balance. Yet behind the scenes, researchers worked tirelessly to cut through the noise. offering clear explanations and sharing real-time updates to keep the facts front and center. Their transparency helped calm the storm, but the media frenzy had already cemented CERN's experiment as one of the most talked-about scientific events of the decade. The world was hooked, not just on the possibility of black holes, but on the drama, the debate, and the sheer audacity of exploring the universe's deepest mysteries. Scientific legacy. And so, long after the first collisions, the true legacy of CERN's bold experiment began to take shape, not in disaster, but in the seismic shift it sparked across the scientific world. The fears of black hole catastrophes faded into the background as the LHC's results fueled a new era of discovery. Among its greatest triumphs was the confirmation of the Higgs boson, the elusive God particle that gave mass to everything in the universe. This breakthrough alone redefined the boundaries of particle physics and earned a Nobel Prize, but the impact didn't stop there. The data collected from the collider's experiments opened doors to questions about dark matter, antimatter, and the very forces that hold the cosmos together. Researchers across the globe dove into the treasure trove of findings, designing new experiments and refining theories that had been debated for decades. The LHC became a symbol of what humanity could achieve when curiosity and collaboration took center stage. Its experiments not only silenced the doomsayers, they inspired a new generation of scientists, engineers and dreamers to push further and dig deeper. The legacy of CERN's black hole quest is written not in fear, but in the relentless pursuit of knowledge and the breakthroughs that continue to ripple through the world of science, reshaping our understanding of the universe with every passing year. The ongoing quest. But curiosity refuses to rest, and at CERN, the quest for answers only grows more ambitious with every passing year. The Large Hadron Collider, once the subject of global suspense, now stands as a launchpad for even bolder experiments. Researchers are ramping up the energy, refining their detectors and dreaming bigger than ever, hoping to uncover new particles, forces, or perhaps even cracks in the very laws of physics. Each experiment is a leap into the unknown, a calculated risk that could unlock secrets about dark matter, quantum realms, or the origins of the universe itself. The excitement in the halls of CERN is contagious, fueled by the knowledge that every breakthrough, no matter how small, brings humanity closer to understanding the fabric of reality. The world watches with anticipation, eager for the next headline, the next discovery that could reshape textbooks and challenge what we think we know. For the scientists, the journey is as thrilling as the destination, a relentless pursuit of knowledge that transforms fear into fascination and speculation into science. The story of CERN's black hole experiment isn't over. It's just the opening chapter in a saga of exploration that promises to keep pushing the boundaries of what's possible, inspiring curiosity and wonder in generations yet to come. Thanks for joining me on this wild journey into the mysteries of CERN and black holes. If you enjoyed exploring the unknown with Space Facts, make sure to hit that subscribe button and ring the bell icon so you never miss our next cosmic adventure. I'd love to hear your thoughts. Drop a comment below and let me know what space fact blew your mind today. Your support helps us keep bringing you the universe's most fascinating secrets. Until next time, keep looking up and stay curious. Intro. Right now, 400 million miles from Earth, a storm larger than our entire planet has been raging for over 350 years, longer than the United States has existed. The Great Red Spot on Jupiter generates winds of 400 miles per hour that could obliterate everything in their path. Yet this cosmic hurricane maintains perfect stability in an environment of absolute chaos. But here's the terrifying truth. This ancient storm is dying, shrinking at 580 miles per year, and when it finally disappears, Jupiter will never be the same again. Did you know that we're literally watching the death of a weather system older than human civilization unfold in real time? The mystery storm discovery. When Juno reached Jupiter's North Pole in July 2016, mission control went dead silent. What they saw defied every computer model, every prediction, every theory about gas giant atmospheres. 8 massive cyclones, each the size of Texas, were arranged in a perfect geometric pattern around a central hurricane that could swallow Earth whole. These weren't ordinary storms. They were maintaining positions with mathematical precision that seemed almost artificial. The southern pole revealed an equally bizarre sight: 6 cyclones locked in a pentagonal formation, spinning at 100 miles per hour while staying 52 degrees Fahrenheit cooler than their surroundings. What terrified scientists most was the stability. On Earth, hurricanes last days or weeks before dissipating. These Jovian monsters have been maintaining their cosmic dance for years, possibly centuries. The Deep Space Network tracking data showed these cyclones weren't just surface features. They were connected to atmospheric rivers flowing thousands of miles deep. It's as if Jupiter operates by entirely different laws of physics, where chaos organizes itself into patterns that shouldn't exist according to everything we understand about planetary atmospheres. Largest eruption recording. The microwave radiometer aboard Juno penetrated deeper into Jupiter than any instrument ever had, and what it found was absolutely mind-bending. Hidden beneath the cloud tops were towering atmospheric structures that scientists dubbed steeple mountains. Invisible giants of gas and energy extending 1,800 miles down into the planet's interior. To comprehend this scale, that's 270 times deeper than Earth's Mariana Trench. These weren't physical mountains but massive atmospheric belts that plunge into Jupiter's core like cosmic elevator shafts. The gravitational measurements from Juno's 54th flyby on September 7, 2003 revealed the shocking truth. Jupiter's atmosphere doesn't end where we thought it did. Instead, it blends seamlessly with the planet's interior in a way that violates our basic understanding of planetary structure. The spacecraft used Jupiter's own gravity as a scanning tool, measuring velocity changes as small as 0.01 millimeter per second from over 400 million miles away. What emerged was a three-dimensional map of a world where the boundary between atmosphere and interior simply doesn't exist. Jupiter isn't just a gas giant with a solid core, it's a fluid, chaotic system where atmospheric storms reach depths that would take you from New York to the center of Earth and back again. Largest eruption recording. Juno uncovered evidence of atmospheric eruptions so massive they make Earth's most violent volcanic explosions look like firecracker pops. The Great Red Spot, that iconic crimson hurricane we've admired for centuries, plunges an astounding 300 miles below the cloud surface, deeper than the distance from Earth to the International Space Station. But this ancient storm, observed since the mid-1600s, is just one player in a symphony of atmospheric violence. Smaller storms reach 60 miles down, while others extend over 200 miles into Jupiter's interior, creating a labyrinthine network of atmospheric chaos that operates in 3 dimensions. The energy scales involved are beyond human comprehension. These storms have been raging for millennia, powered by forces that dwarf anything in our solar system. NASA's precision instruments detected atmospheric explosions that release more energy in a single event than Earth receives from the Sun in an entire year. The Deep Space Network measured these eruptions with incredible accuracy, revealing that Jupiter's weather system isn't just more violent than Earth's, it operates on completely different principles. While our storms are temporary disturbances in a stable atmosphere, Jupiter's storms are permanent features of a world in constant atmospheric rebellion against the laws of physics as we understand them. Jupiter's magnetic field. The magnetometer investigation aboard Juno revealed that Jupiter's magnetic field is not just stronger than expected, it's completely alien in structure. Jack Connerny from NASA's Goddard Space Flight Center led the team that created the most detailed magnetic map ever made of another planet, using data from 32 orbits around the gas giant. What they discovered was terrifying. A magnetic field more than twice as powerful as models predicted, with an irregular, chaotic structure unlike anything seen before. The most unsettling discovery was the Great Blue Spot, a massive magnetic anomaly at Jupiter's equator that's drifting eastward at 2 inches per second, completing a full lap around the planet every 350 years. This isn't just a magnetic field, it's a cosmic scar. Scientists believe meteorite impacts billions of years ago modified Jupiter's magnetic structure, which is now frozen in a superconducting core, like a permanent record of ancient cosmic violence. Even more disturbing is the discovery of secular variation. The magnetic field is changing over time, something previously only detected on Earth. Jupiter carries the magnetic memory of collisions that happened when the solar system was young and chaotic, making the planet a living museum of cosmic catastrophes that shaped the worlds we see today. Atmospheric water mystery. Juno's microwave radiometer has been conducting the ultimate planetary autopsy, using 6 antennas to X-ray hundreds of kilometers below Jupiter's cloud tops. And what it's finding about water content is rewriting the textbooks on planetary formation. For decades, scientists assumed Jupiter formed beyond the frost line where water should freeze and accumulate in massive quantities. The planet should be soaked with water vapor, but Juno's measurements are revealing a distribution so patchy and unpredictable that it's forcing us to reconsider everything about how gas giants form. The water mystery cuts to the heart of solar system formation theory. If Jupiter's water content doesn't match our models, it suggests the early solar system was far more violent and chaotic than we ever imagined. The implications are staggering. It could mean that planets don't grow peacefully by accumulating material, but are forged in cosmic disasters that fundamentally alter their composition. Juno's deep atmospheric scans are essentially performing cosmic archaeology, peering into Jupiter's interior to read the story of its formation, written in water vapor concentrations. What they're finding suggests that Jupiter didn't form where we think it did, or that massive collisions during its formation scattered water in ways that defy current planetary formation models. The planet is keeping secrets about the early solar system that could change our understanding of how Earth and every other world came to exist. Polar cyclone dynamics. The poles of Jupiter are cosmic madness manifested in 9 cyclones arranged in perfect geometric symmetry around the North Pole, 6 cyclones forming a pristine pentagon around the south. NASA's navigators have been tracking these atmospheric beasts with surgical precision since Juno's arrival in July 2016, and what they've discovered violates every principle of atmospheric dynamics we know. Each cyclone spans nearly the width of the continental United States, spinning at incredible velocities while maintaining their positions like cosmic clockwork. On Earth, storms are temporary chaos that forms and dissipates. But Jupiter's polar cyclones have been locked in their geometric dance for years, possibly centuries. They resist change with an almost intelligent stubbornness, forming what scientists describe as a private club that seem to resist new members. The data reveals these aren't just surface storms, they're massive atmospheric columns extending thousands of miles into Jupiter's interior, connected to the planet's deep atmospheric rivers like cosmic pillars holding up the sky. The precision of their arrangement suggests forces at work that we don't understand. Atmospheric dynamics operating on scales and timescales that make Earth's weather look like child's play. These cyclones are essentially atmospheric monuments, permanent fixtures in a world where chaos has somehow organized itself into mathematical perfection that shouldn't be possible according to everything we know about fluid dynamics and planetary atmospheres. Jupiter's composition and structure. Juno's gravitational measurements have shattered our most fundamental assumptions about Jupiter's interior structure. The spacecraft has revealed that the king of planets doesn't have a solid core like textbooks claim. Instead, it harbors a fuzzy core made of rock fragments and metallic hydrogen scattered throughout its interior like cosmic shrapnel. This discovery is revolutionary because it suggests Jupiter's formation was catastrophically violent, likely the result of a massive collision that occurred during the early solar system's chaotic youth. Juno acts like a cosmic detective, using tiny velocity changes to map the distribution of mass inside Jupiter. By measuring gravitational variations as small as 0.01 millimeter per second from hundreds of millions of miles away, scientists can essentially see through the planet's layers. What they're finding is that Jupiter's interior is not the neat, layered structure we expected. It's a chaotic mixture where different materials are scattered in patterns that speak of ancient violence. The implications are staggering. If Jupiter was fundamentally altered by a collision, it means planetary formation in our solar system was far more destructive than we thought. Planets aren't just peaceful accumulations of cosmic dust and gas, they're the survivors of cosmic wars fought billions of years ago, carrying the scars of impacts so massive they can reshape entire worlds and alter the course of planetary evolution forever. Great Red Spot Analysis. The Great Red Spot has been Jupiter's most iconic feature since telescopes first revealed it in the mid-1600s, but Juno's close-up analysis has unveiled a storm so complex and alien that it's forcing us to redefine what we thought we knew about atmospheric phenomena. This isn't just a hurricane, it's a 300-mile-deep atmospheric monster that extends from the cloud tops down into Jupiter's interior, further than the distance from Earth's surface to the International Space Station. Juno's instruments have mapped the storm's three-dimensional structure, revealing a spiraling tower of gas and energy that operates like a cosmic tornado lying on its side. The storm's winds reach speeds that would instantly destroy anything on Earth, while temperatures and pressures at its base approach conditions found in the cores of rocky planets. What makes the Great Red Spot truly terrifying is its permanence. This storm has been raging continuously for over 400 years, possibly much longer. It's a weather system older than most human civilizations, powered by energy sources we're only beginning to understand. Juno's data reveals that the spot is connected to Jupiter's deep atmospheric layers, drawing energy from the planet's interior heat like a cosmic engine that never stops running. The storm is essentially a window into Jupiter's soul, a permanent scar in the atmosphere that reveals the violent, chaotic nature of a world where weather operates on scales and timescales that dwarf anything in human experience. Jupiter as planetary protector. Juno has documented Jupiter's role as our solar system's bodyguard in terrifying detail, revealing a cosmic protector that's constantly under siege from interplanetary debris. The spacecraft observed a meteor impact in April 2020 with an estimated mass of 250 to 5,000 kilograms, just one of countless projectiles that Jupiter's massive gravitational field captures before they can hurtle toward the inner solar system. Without this cosmic vacuum cleaner, Earth would face regular bombardment from asteroids and comets, making complex life nearly impossible. Juno's observations show that Jupiter is essentially sacrificing itself for the rest of us, taking hit after hit from space rocks while we orbit safely in the inner solar system. Each impact creates massive explosions visible from hundreds of millions of miles away, releasing energy equivalent to multiple nuclear weapons. The planet's gravitational influence extends far beyond its physical size, reaching out like invisible tentacles to snare dangerous objects that might otherwise threaten Earth. But this protection comes at a cost. Jupiter is constantly being bombarded, its atmosphere churned by impacts that would sterilize entire continents on Earth. The planet stands as a cosmic shield between us and the chaos of deep space, a guardian world that absorbs the violence of our solar system's debris-filled void. Juno's documentation of this protective role reveals that our existence might depend entirely on Jupiter's willingness to serve as the solar system's punching bag, standing between civilization and cosmic annihilation. Jupiter's magnetic field. The death of Jupiter's most famous storm is happening before our eyes, and Juno has given us ringside seats to watch a cosmic legend fade away. Amy Simon from NASA's Goddard Space Flight Center has been tracking the Great Red Spot's decline using Hubble Space Telescope observations, documenting a shrinkage so dramatic it's rewriting our understanding of atmospheric longevity. The spot has contracted from 25,500 miles across in the late 1800s to just 10,250 miles today, less than half its historical size. Beginning in 2012, amateur astronomers noticed the shrinkage accelerating to an alarming 580 miles per year, transforming the storm from an oval to a circle as it literally starves to death. Yale PhD student Caleb Kevaney and his team have developed computer models showing that the Great Red Spot is essentially eating itself. Smaller storms that once fed it energy are becoming less frequent, leaving the giant hurricane to slowly consume its own substance like a cosmic Ouroboros. Their simulations predict the spot could shrink to nothing in approximately 2.6 Earth years, marking the end of a weather system older than human civilization. The implications go far beyond losing a famous landmark. The Great Red Spot plays a crucial role in Jupiter's atmospheric dynamics, and its disappearance could trigger changes throughout the planet's entire weather system. We're witnessing the transformation of Jupiter itself, watching a world that has remained essentially unchanged for centuries suddenly evolve before our eyes as its most iconic feature slowly fades into cosmic history. That's the incredible reality of Jupiter, a world so alien and violent that it challenges everything we thought we knew about planetary science. Juno's mission officially ends in September 2025, but the mysteries it has uncovered will keep scientists busy for decades. From dying storms to magnetic anomalies that defy physics, Jupiter continues to prove that our universe is far stranger and more terrifying than we ever imagined. What discovery shocked you the most? Drop your thoughts in the comments below. If you're fascinated by the cosmic mysteries lurking in our solar system, Make sure to hit that subscribe button and ring the bell icon so you never miss another mind-blowing episode from Space Facts. Until next time, keep looking up. What if the most significant discovery in astronomy wasn't just another space rock but something far more extraordinary? Recent observations of 3I Atlas have revealed characteristics so unusual that some scientists are questioning everything we thought we knew about interstellar visitors. This cosmic wanderer's behavior is challenging our understanding of what's natural in the universe. Discovery and initial detection. What are the odds of spotting a cosmic needle in the infinite haystack of space? On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, achieved exactly that, detecting a faint moving object initially catalogued as A11PL3Z. This discovery marked a historic moment as astronomers realized they had found the third confirmed interstellar object ever detected by humanity. Following the groundbreaking discoveries of 1I Oumuamua in 2017 and 2I Borisov in 2019, this new visitor was officially designated 3I Atlas, and given the cometary classification C2025N1. However, what makes this detection particularly intriguing is that despite its eventual brightness, 3I Atlas remained hidden from earlier detection due to its challenging viewing angle as it approached from the direction of the Sun. This late discovery, despite the object entering our solar system months earlier, raises questions about how many other interstellar visitors might have passed through undetected. The object's trajectory and timing suggest it may have been deliberately positioned to avoid early detection, a characteristic that has captured the attention of astronomers worldwide. Within days of confirmation, observatories globally began tracking this mysterious visitor, but its behavior would soon challenge conventional explanations for interstellar objects. Extraordinary orbital characteristics. How can an object from interstellar space follow a path so perfectly designed for studying our solar system? 3. I-Atlas possesses orbital characteristics that defy the laws of probability and challenge our understanding of random cosmic motion. The object follows a hyperbolic orbit with an extreme eccentricity of 6.14, making it the most hyperbolic trajectory ever recorded for any confirmed interstellar object. Racing through space at an incoming velocity of 58 kilometers per second, it holds the record as the fastest interstellar visitor humanity has ever detected. What makes these characteristics truly extraordinary is the object's trajectory alignment. Its path lies almost perfectly within the ecliptic plane, with astronomers calculating only a 0.2% probability of such alignment occurring by random chance. This precise positioning allows 3I Atlas optimal viewing angles of all major planets in our solar system, resembling a carefully planned survey route rather than the chaotic trajectory expected from a naturally ejected object. The mathematical precision of this path has prompted some researchers to question whether natural gravitational interactions alone could produce such an unlikely orbital configuration. Unlike typical interstellar objects that enter our solar system from random directions, 3I Atlas appears to follow a route specifically designed for comprehensive planetary observation, raising profound questions about the true nature of this enigmatic visitor from the depths of interstellar space. Suspicious planetary encounters. What are the chances that a random visitor from interstellar space would pass by every major planet in our solar system? The trajectory of 3I Atlas presents astronomical improbabilities that challenge conventional explanations for natural objects. Calculations reveal that this mysterious visitor will pass unusually close to Venus, Mars, and Jupiter, with astronomers determining only a 0.005% probability that such planetary encounters could occur by random chance. Even more suspicious is the timing of its closest approach to the Sun, which occurs precisely when Earth's position blocks optimal observation opportunities, an event with only a 7% probability of random occurrence. This strategic timing ensures that 3I Atlas remains partially hidden during its most vulnerable moment of solar approach, when increased solar heating would reveal the most about its composition and internal structure. The object's path resembles what mission planners would design for a reconnaissance spacecraft conducting a comprehensive survey of our solar system. Each planetary encounter provides optimal positioning for studying gravitational effects, atmospheric compositions, and planetary characteristics that would be valuable to any advanced civilization seeking to understand our cosmic neighborhood. The mathematical precision required to achieve such a trajectory through natural ejection processes appears virtually impossible, leading some researchers to suggest that 3I Atlas might represent something far more sophisticated than a simple interstellar comet drifting randomly through the galaxy. Physical properties and anomalies. How can an object be simultaneously ancient beyond imagination yet surprisingly well preserved? 3I/Atlas presents a fascinating paradox in its physical characteristics that, honestly, challenges our understanding of interstellar object evolution. With an estimated diameter ranging from 1 to 12 kilometers, it's significantly larger than previous interstellar visitors, making it the most substantial confirmed object from beyond our solar system. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating the formation of our entire solar system by billions of years. Despite its ancient origins, 3I/Atlas has earned the distinction of being the brightest interstellar object ever observed, reaching magnitudes that allow detailed study with ground-based telescopes. The object exhibits a 29-hour rotation period with remarkably minimal brightness variations, suggesting an unusually spherical or elongated shape that maintains a consistent cross-sectional area as it spins. What puzzles astronomers most is how an object of such extreme age could maintain its structural integrity during billions of years of interstellar travel, surviving impacts from cosmic dust, radiation bombardment, and gravitational perturbations from passing stars. The preservation of such an ancient artifact raises questions about its composition and internal structure. Most naturally formed objects of this age should show significant weathering and fragmentation, yet 3I/Atlas appears remarkably intact, leading some researchers to speculate about unusual material properties or construction methods that could explain its extraordinary longevity. Comet-like features versus anomalous behavior. Why does 3I/Atlas simultaneously behave like a typical comet while displaying characteristics that contradict cometary physics? This interstellar visitor presents a confusing mixture of expected and anomalous behaviors that have astronomers scratching their heads. On one hand, the object displays clear cometary features, including a faint coma and a short 3 arc-second tail, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations confirm the presence of water vapor and dust particles being ejected from the nucleus, creating the familiar fuzzy appearance associated with comets approaching the Sun. However, several characteristics deviate significantly from typical cometary behavior and challenge conventional understanding. Unlike normal comets that develop extensive flowing tails as they approach the Sun, 3I/Atlas maintains a remarkably compact and dense appearance despite its proximity to our star. The expected dramatic tail development that should occur during solar approach appears mysteriously absent or significantly suppressed. Additionally, the object's outgassing patterns don't follow the predictable models used for solar system comets, with activity beginning much earlier and following unusual intensity patterns. The combination of recognizable cometary features with anomalous behavior patterns creates a scientific puzzle that defies easy categorization. Some researchers suggest these contradictions could indicate an artificial origin designed to mimic natural cometary activity, while maintaining structural advantages that prevent the typical fragmentation seen in natural comets during close solar encounters. Scientific debate: natural versus artificial. Could humanity be witnessing the first confirmed artificial object from another civilization? This question has sparked intense debate within the astronomical community, with Professor Avi Loeb from Harvard University leading controversial discussions about 3I/Atlas's potential artificial origins. Loeb points to the statistically improbable trajectory, precise planetary encounter timing, and anomalous physical characteristics as evidence that this object might represent advanced technology rather than natural formation. His arguments center on the mathematical impossibility of achieving such a perfectly designed reconnaissance trajectory through random gravitational ejection from a distant star system. The object's strategic positioning for optimal planetary observation while minimizing detection opportunities suggests intentional design rather than cosmic coincidence. However, the majority of the scientific community strongly opposes these interpretations, dismissing such claims as irresponsible speculation that, honestly, undermines serious astronomical research. Leading planetary scientists argue that unusual characteristics can be explained through natural processes we don't yet fully understand. pointing to the complex dynamics of planetary system formation and ejection mechanisms. They emphasize that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide sufficient proof of artificial construction. The debate highlights fundamental questions about how we interpret anomalous data and the criteria required to consider non-natural explanations. This scientific controversy demonstrates the challenges of studying truly unprecedented phenomena that push the boundaries of our current understanding. Spectral analysis mysteries. So, what happens when the chemical fingerprints of an object contradict everything we know about cosmic ice? Well, spectroscopic analysis of 3I Atlas has revealed some pretty puzzling discrepancies that, honestly, challenge our understanding of interstellar object composition. While initial observations detected the expected water ice spectrum, a more detailed analysis actually reveals significant anomalies in the spectral patterns. The observed signals rise precisely where theoretical water models predict they should drop. And this creates a scientific puzzle that's got researchers questioning their fundamental assumptions about cometary composition. This unusual spectral behavior suggests either unknown ice structures formed under extreme interstellar conditions, or maybe even the presence of exotic materials not found in typical solar system objects. The object's distinctive reddish coloration adds yet another layer of mystery, resembling asteroids from the outer asteroid belt, rather than the neutral or blue colors we usually see in pristine comets. Standard models just can't adequately explain this color combination along with the observed outgassing patterns, which suggests some pretty complex surface chemistry, likely altered by billions of years of cosmic radiation exposure. And to complicate matters even further, the active coma surrounding the nucleus interferes with spectroscopic measurements, making it tough to distinguish between emissions from the solid surface and gases in the surrounding cloud. Advanced computer modeling, which tries to separate these contributions, has so far yielded inconsistent results, with some analyses even suggesting the presence of materials that really shouldn't exist in natural cometary bodies. These spectral mysteries have prompted some researchers to consider whether 3I Atlas might contain artificial materials or, maybe even represent a type of object completely unknown to current astronomical science. Dark forest hypothesis implications. Could 3I Atlas represent evidence of a cautious alien civilization following the theoretical dark forest hypothesis? This controversial idea suggests that advanced civilizations, remain hidden to avoid detection by potentially hostile neighbors, conducting reconnaissance missions while minimizing their own exposure. The behavior of 3I Atlas, honestly, eerily matches this theoretical framework, displaying what appears to be deliberate stealth-like characteristics designed to avoid detection during its most vulnerable moments. The object's trajectory ensures it remains partially hidden behind the sun during its closest approach, when increased solar heating would reveal the most information about its internal structure and composition. This strategic positioning allows comprehensive study of our solar system while minimizing opportunities for detailed observation by Earth-based telescopes. The timing and trajectory appear designed for maximum information gathering with minimum exposure risk, resembling the cautious exploration strategy that an advanced civilization might employ when investigating a potentially inhabited star system. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that civilizations remain silent because revealing their location invites destruction by more powerful neighbors. If 3I Atlas represents such a reconnaissance mission, its behavior demonstrates remarkable sophistication in balancing scientific objectives with survival instincts. The possibility that we're witnessing humanity's first encounter with alien technology conducting a stealth survey of our solar system raises profound questions about cosmic civilization protocols and our place in a potentially crowded but silent galaxy filled with hidden watchers. Historical context and lessons. The discovery of 3I Atlas carries profound implications shaped by our previous experiences with interstellar objects and, the scientific opportunities we failed to fully capitalize on. The first interstellar visitor, 1I Oumuamua, caught astronomers completely off guard when Robert Warwick detected it using the Pan-STARRS 1 telescope in 2017. The object's unexpected rapid exit from our solar system left the scientific community with more mysteries than answers, particularly regarding its strange acceleration behavior that just defied conventional explanations. This missed opportunity, honestly, highlighted critical gaps in our rapid response capabilities for studying rare cosmic phenomena. The second interstellar object, 2I Borisov, discovered by amateur astronomer Gennady Borisov at his Crimean Observatory in 2019, provided a redemption opportunity that was better utilized but still constrained by available technology and coordination limitations. Mark Norris from the University of Central Lancashire emphasizes that 3I Atlas represents our most comprehensive opportunity to date for properly investigating an interstellar visitor using advanced instrumentation and coordinated global observation strategies. The improved detection capabilities of contemporary sky survey systems, combined with enhanced international communication protocols, have enabled unprecedented real-time coordination among research facilities worldwide. Michelle Bannister notes that these lessons learned from earlier interstellar encounters have truly revolutionized our approach to studying these remarkable cosmic messengers. Future observations and implications. What will the next few months reveal about the true nature of this enigmatic visitor? 3I Atlas will reach perihelion on October 30, 2025, providing the most critical observation window in its entire passage through our solar system. Following this closest solar approach, the object will re-emerge from behind the Sun in December 2025, offering a final opportunity for comprehensive analysis before it begins its permanent departure from our cosmic neighborhood. Multiple telescopes worldwide are coordinating the most ambitious interstellar object observation campaign in astronomical history, including space-based platforms like the James Webb Space Telescope and Hubble Space Telescope. These coordinated observations aim to resolve fundamental questions about the object's composition, internal structure, and true nature before it becomes too distant for detailed study. The data collected during this critical period could revolutionize our understanding of interstellar objects and their implications for planetary defense strategies. If 3I Atlas proves to be artificial, the discovery would represent the most significant moment in human history, confirming that we are not alone in the universe and that other civilizations are actively studying our solar system. Alternatively, if proven natural, the object would still provide unprecedented insights into planetary formation processes in distant star systems and the evolution of materials during billions of years of interstellar travel. Either outcome promises to transform astronomy and our fundamental understanding of our place in the cosmos, making the coming months among the most important in the history of space science. As 3I Atlas approaches its moment of truth during perihelion, it carries with it the potential to answer humanity's most profound question: are we alone? Whether this mysterious visitor proves to be an ancient comet or something far more extraordinary, it represents a pivotal moment in our understanding of the cosmos. For more groundbreaking space discoveries that challenge everything we thought we knew, subscribe to Space Facts, where the universe reveals its most stunning mysteries.